Okay.
Perfect. Thank you very much. Okay, so I was saying, let me first briefly mention what the workshop is going to be. It's going to be 45 minutes, and the goal for us is to share an update on the standard that we're working on. The group has been formed around 2 years ago. A lot of work has been going in. We published a white paper, and I'll mention, along some of the work that has gone into that, what you'll find there. And we are also about to publish a white paper specifically on the data model, but you'll see, all of the details there. So let me first introduce the next speakers, and then we'll start with a brief introduction and then the meat of the presentation. So first, Vatsa Prahallada is operating as a technical director in design enablement organization at NXP San Diego. He's handling automotive and automation solutions. And prior to this, he has experience working at Intel and Qualcomm in physical design, post-silicon, simulations and functional safety teams at different capacities. He has a passion towards tools, flows, methodology development, and he's an automation evangelist. Okay, so that's our first speaker. And the second speaker is Darren Galpin. He's a principal digital verification engineer at Renesas in the UK, working on automotive power management devices since September last year. And prior to this, he worked at Infineon Bristol in the automotive group, primarily as a verification engineer in the Oryx real-time cluster team, and additionally as a concept engineer supporting the high-speed internet interconnect and the non-volatile memory team, as well as methodologies. So he has also worked at ST Microelectronics in verification and product engineering, and he's the secretary of the IEEE Functional Safety Standards Committee and the chair of the IEEE 1647 Functional Verification Language Group. Okay, so you have not only 2 experts on functional safety, but 2 very active members of the group, of the Accellera working group. So you can go to the next slide, please. So this is the agenda. I'll start a few minutes about the introduction to the working group, the mission and everything you'll find already in a white paper, but we'll summarize it. It's useful for the rest of the presentation. Vatsa will cover the second part, which is the FMEDA formalization process and the functional safety data categories that we identified. And then Darren will continue with more details about the conceptual data model and some of the methodology discussions that are very active in the group right now. And then I'll close, just a couple of slides, depending also on how much time we have left on the future work that the team is working on. Okay, so if you can go to the next slide, please. So this slide is a summary of the mission of the group and why we're doing this. So we've done, the first part of the work has been identifying the need, identifying where the problems are that we feel we could address. And the 5 buckets that you see on the left are the challenges, that the way we have categorized them. And you'll see all the details in the first white paper we published last year in May. So the first category is exchange of same functional safety data across different automation tools, then connection between the functional safety data and the design information. The third is sharing of different functional safety data across operations and work products in the same layer. And by same layer, we mean most of the time the same provider. And then the fourth one is the exchange of functional safety data between suppliers and integrators. And then the fifth is kind of, a category that goes across the others, is traceability of information across the distributed development environment. So all of these 5 challenges, or buckets of challenges, we feel can be solved with a functional safety data format or language that helps us capture and propagate the functional safety data. And next slide will cover exactly what we mean. But before we go there, the goal for us is to improve the 3 hexagons you see on the right: interoperability, traceability, and automation. Okay, if we go to the next slide, which is very dense of information here. So let me explain this picture because it has many dimensions. But you see in the center is functional safety data, which is what I mentioned in the previous slide. This is the work we are doing. We are trying to capture the set of data that is needed to perform safety activities and generate work products. And so you can see connected to that central functional safety data, activities and work products, as I just mentioned, assumptions of use, safety requirement, FMEA, FMEDA, like the whole list, and the safety case. And so we feel that this set of data will help generating this, will help the interoperability and the generation of these work products. The idea is that it can go interlayer, meaning in between the different supply chain levels. So from the IP to the component, from the component to the module, from the module to the system, and vice versa if needed. And then also intra-layer. So within, let's say, an IP provider, what is the functional safety data needed to exchange, for example, data between FMEDA and DFA? Yes. So this picture captures many angles. And we feel EDA is kind of an enabler of all of this. Okay, so when you see the picture in the middle, it doesn't mean it's only related to component and module. It's actually across all of the 4 layers that we're showing here. So if you go to the next slide, please. How does this sit with the rest of other standards that are already existing? So the idea is that the functional safety standard we are developing is going in addition to the existing design standards. So the box that you see on the left that includes the design standards, for example, Verilog, VHDL, System Verilog, System C, whatever, we're not going to interfere with those. They are actually complementary. What we're capturing is in addition, so that together they give us a definition, a design definition for safety activities. And then what you see on the right is, the box that shows, at the conceptual level, the V model. Meaning, hopefully this standard will allow you to go through the V model, through different, different phases of the life cycle and generate the functional safety working products you need. Okay. So if you go to the next slide, please. I just wanted to explain how we fit in the landscape of standardization, because there are already a lot of standardization activities around safety. So let's start to the bottom left. I think this picture has been seen in several places. There is the original 61508 standards on functional safety of PEP systems, and then the derivatives of those, specifically automotive, industrial, medical, automation, aviation, railways, and machinery. And so in terms of scope, as I said, we have many angles, right? And initially we are focusing on the automotive one, but we'll extend to the others. The point we want to make here is that these existing standards are already defining the best practices and guidelines. We're not changing those. What the plan is, what we've seen is putting in practice these best practices and guidelines can have some challenges. So there are challenges for implementation. And those are the ones that I mentioned, the 5 buckets that we have identified as a group. And so the idea is that the functional safety working group is working to defining a functional safety standard with the goal to have higher efficiency, higher confidence in implementing the best practices. Okay, so we think we are an enabler of existing best practices and guidelines. So what you see also on the right is a direction towards another standardization group, the IEEE P2851. There is a historical collaboration between Accellera and IEEE. Several standards have been developed and published at Accellera as Accellera standards. And once they are matured, after a few years of the industry using them, being refined and finalized, then they are passed to IEEE for publication. And that's the same framework that we have here. So I think just a very quick point here on what are our next steps. What you see on the left is a draft of the white paper that contains the data model. So this is in addition to the white paper we published last year. I put the table of contents because it's actually very useful to show you the type of information we are gathering in this paper. Vatsa will cover essentially the first few, the FMEDA process, the design, representation, and mapping of data, why we did that and what we're doing, like, why did we need it? And then also, and then Darren will close with showing you a sample of the conceptual data model. Not all of it because it's quite complex, but giving you kind of an idea of the type of information we are gathering and how, okay? And so we are hoping to publish this. We were hoping Q1, but we have had some fierce discussion about a few things. So I think it will become Q2. And then what we plan to do is establish a forum for gathering public feedback. So once the data model is published, then we'll figure out a way to get feedback externally also to the working group. So just one word of caution here, this is all work in progress. It's a working group, nothing is being finalized yet. So what you hear today is progress the team has made. Things can change. As I said, there are very fierce discussion, very lively, interesting discussions. And with that, I think I'll stop and pass it to Vatsa. Thank you very much.
Can you guys hear me?
Yes.
And can you see me?
Yes.
Okay, awesome. All right. Thank you, Alessandra, for the introduction. Hi, everyone. In this segment, I'll be discussing about FMEDA formalization process and data categories. Okay, why data model? Let's start with that. Like already, Alessandra briefed about ISO 262 and also the relationship with the Accellera functional safety. Let's go and kind of understand the work products, right? Although ISO 26262 talks about various work products, we need to define a method that can operate at various stages of silicon development at various levels of design hierarchies. Accellera is trying to complement the standards by defining the data models. The task related to FMEDA data model has been layered into 3 steps. The first step has been to arrive at a consensus on a generic approach which serves the concurrent practices and flexible enough to serve the currently foreseen methods in the future as the product development methodologies and technologies are evolving. Formalization of the functional safety analysis process is the first step that should lead to the development of conceptual data model. Finally, the activity shall culminate into data model language, which should enable, again, like Alessandra specified, interoperability, traceability, and automation. So let's talk about interoperability. The ability and the effectiveness of exchanging the information. It is like a 2-dimensional matrix, as we saw in the previous slide. It is the exchange of the same FS content across different automation tools and sharing of different FS content across different operations or work products in the same layer, right? Intra-layer and interlayer. Traceability, it's pretty known and also well explained in ISO 26262. But what we want to achieve is that the ability to trace and verify the history and the connection of the information by the means of recorded identification. And of course, automation, which is the usage of EDA tools to automate the task of manipulating, storing, and exchanging the information. The most visible need for automation is the connection between functional safety content and the design information. So let's talk about FMEDA process. The FMEDA systematic analysis is a bottom-up inductive analysis of the ways the component of an architecture can fail and how the device architecture can mitigate. And when I say mitigate, it is like detect or control such failures to maintain a safe state. So there are 6 boxes. We'll start with that. I'll start with design under analysis. It is a comprehensive list of all the components, typically hierarchical. Functional safety analysis hierarchy, the portions of the design which are safety related and which have the potential to violate the safety goal or the safety requirement. So failure mode hierarchy is an enumeration process of the possible failure modes of each component that can cause its failure to function as specified, right? Failure mode effects, basically the effects caused by the failure modes that are at the component level, and it is against the top level safety goals or functional safety requirements of the system. A safety mechanism library is a set of approaches which can mitigate, again, either detect or even correct each component failure mode to bring the system to a safe state within the requisite time. And technology elements are within the design under analysis. So let's understand the functional representation. This is quite interesting. This slide and the next slide talks about understanding the design representation at both functional level and at structural level. So as we know, a design will have multiple representations as it matures through the design or development lifecycle. And the safety analysis can be performed on any representation. It can be at abstract level, or it can be at more concrete levels. For instance, a functional representation of the design happens in the early development lifecycle. Here, the design is represented by the hierarchy of functions and subfunctions with their interfaces and interconnections. At this stage, specific implementations such as target technology may have not been selected. This diagram tries to explain one such example. Observe that failure modes are purely functional in nature. It is based on the functionality of the system. See here, send function fails to occur, send function occurs. These are all functional, right? But this slide basically talks about the structural equivalence of it. Again, we have tried to demonstrate the equivalent structural representation along the failure modes. And because we know the structure of the system, our failure modes now can be more specific. For example, tuner unit has too much of static. So you have the structure in place. So this is basically the metamorphosis of functional safety along the side of your design. So the layers of supply chain represent a distributed development environment with multiple organizations, suppliers and customers, right? It is important to note that the concept of functional and structural design representation apply to all layers of supply chain. It can be at IP level, component level, module, or even system level. Again, I'll probably pick one example from these product examples, right? Maybe we can take DDR at the IP level. That can be represented as a block diagram and, of course, as an RTL. If you look at the component layer, it can be an SoC chip, a processor. Again, it can be represented definitely at RTL or even SysML. Module level is like a bare metal ECU. I mean, you have the ECU, but you do not have the sensors and actuators yet. It can be represented using any system modeling techniques. And of course, at the system level, where you have the complete integrated ECU, it can be again represented at system modeling level. So in summary, the independence of design representation is critical in supporting the various scenarios encountered performing functional safety analysis within and across supply chains. So, so now this is the same diagram, but now after applying the concepts of design representation to FMEDA process, we have the mapping defined, whatever you see in the gray double-headed arrows, right? So what is mapping? Mapping is defined as the operation of connecting a set of data to another, right? In the context of Accellera function safety data model, mapping is the connection of elements of the design representation to another data set to support and automate functional safety analysis activities. Let me explain the concept of mapping by taking design mapping as an example. It is the mapping between source design that can be represented in any design representation. We already discussed about it, to the functional safety analysis hierarchy. Again, to express this idea in a more concrete example, we are using OR 1200 open source risk processor structural hierarchy. Let me go to that slide. Once you accept the simplification of the given design, the part is mapped to the top, and the subparts are mapped to MAC, MMU, and Dcache RAM, respectively. It is important to note that the definition of functional safety hierarchy is not required to align to the design hierarchy. Check out the data model. Again, it might be an eye chart, but the model is representing the following. The top is mapped to, of course, top, but MAC is mapped to top DMMU top and top IMMU top. Dcache RAM is mapped to DC top and DC RAM. A closer look at MAC is an example that actually demonstrates the mapping is not one-to-one, because for more practical cases, it can be N-to-M kind of a mapping. Similarly, the mapping are defined for all the other entities in the diagram from the previous slides. And again, Darren will cover few more details. So functional safety data categories. Based on some of the intuitive guidelines and rational consensus, Accellera is proposing following data model with a given set of guidelines. Again, the highlight here is Accellera is providing a set of guidelines. Let me mention a few guidelines here. Start with the simplest model and add complexity only if there is any specific cases which are already not supported. In general, the more complex or you're trying to make it more flexible, the model, the more rules and are there, and then there is a need to ensure consistency and exchangeable models. Select attributes to allow the smallest granularity needed, and so on and so forth. FMEDA, now we all know that FMEDA is the analysis and it's the anchor point. Let's take the FS hierarchy again. Maybe it's an eye chart, but we already saw in the previous slides that we conducted design mapping between design under analysis to the functional safety analysis hierarchy. That's where we actually tied the part and the subpart that we identified. Similarly, the table shows the other high-level categories and corresponding entities. This is described in a very detailed way in the paper that we are talking about. This is a brief overview of formalization and data categories for functional safety. Like Alessandra mentioned, Accellera Group is actively working on one or more changes developing formalization and standardization. So feel free to check out our website, check out the paper once it is published, and know more how to get involved. Darren will now cover the conceptual data model and related methodologies. Over to you, Darren.
Okay, thank you very much, Vatsa. If you could,
Darren, quick question: do you want to share so that, or
if you could, please?
I can continue.
Yeah, please. Thank you. Okay, so the conceptual data model and methodology discussions. If we can go to the next slide, please. So large parts of this have already been covered by Vatsa, but basically, if we're doing a full set of functional safety data, which we may wish to transmit between the different layers, we need to capture all the different things that the different parties would be interested in. So you have the functional safety analysis hierarchy, the parts and subparts we've mapped to. We need the failure mode hierarchy. We've got technology elements. By that, we mean what type of technology are we using? Is it a RAM, a ROM? Is it analog, digital? And we need to define that. And we also need to define the sources we are using for those technology elements to say where the failure rates are coming from. So for example, whether it's Siemens norm or the IEC 62380. We've got the failure mode effects. So where would the failure mode be observed, which could be of particular interest when we're talking intra-layer rather than inter-layer. We have safety mechanisms. You may want to start creating a library of these so that you can share around, but we need to record what we're using to give us the diagnostic coverage. And then, as mentioned on Vatsa's slide, we've got the various mappings we need so that we can tie them all together and tie them to the design, so that rather than just having disparate collections of data, we have a whole where all of the data is coming together to tell us a safety story. So next slide, please. Okay, so this is just to kind of give an overview of the analysis process as we're viewing it within the working group. So at the beginning, you can see we've got the initial generic structure, which we then need to decide which elements we are actually going to analyze for safety, which hierarchies we're not going to expand further. So basically where we're going to go down to the lowest elements for analysis, because it's at the lowest elements that we have the failure modes. So the failure mode, yeah, Carol. So the failure modes are all at the leaves of the analysis tree and are only in the elements which we're considering for functional safety analysis. Obviously, there could be blocks in there which are not considered for analysis, and we need also to flag which ones they're not. All right, so next slide, please. So looking at the leaf cells and at the lower level, what is it that we actually need to try and record? And this is looking at only a section or a selection of the elements rather than all of the ones that we previously mentioned. So if we're coming to a subpart, obviously we need to have a name and have a description to say what that subpart is, because a subpart, although we've mentioned it before, could actually be part of a real block, or could be several. It's basically a logical description of what we're using for the analysis, and we need some way of mapping it. And the reason I have calc only on the slide is we envisage there are two possible ways you would do an FMEDA. You have an assumption-based one, which you could do early in the life cycle, and a calculation-based one when you're later have really decided what you're going to use for the safety mechanisms and you have some real data on the failure rates and for diagnostic coverage. If you're a subpart, you want the part name it is tied to and the FMEDA name, and whether this particular subpart is safety relevant or not. This subpart is then tied to a failure mode, and the blue arrow here shows where the subpart name is recorded when you are defining a failure mode. Now you can see here, because in a failure mode and also in safety mechanisms, we have names and we're linking them together, that it should be theoretically possible in future that you start to build libraries of these, especially if you're within a company where you have a common set of failure modes across your devices, and then you pull them out of those libraries and state which FMEDA they're in and what they're being mapped to. So if you're a failure mode, we need to know what the name of it is and the description. Again, we've got mapping, which subpart we are tied to and in which FMEA. The type of failure mode it is, whether it's passive, active, or emission mode. Again, whether the failure mode is safety relevant. Various parameters to say how much we are covering within the design, and various diagnostic coverage for whether it's like transient, permanent, or other things that we may decide or that need to be recorded. Then we have the safety mechanisms themselves. As with everything else, they also have a name and a description. We also say what the class of the safety mechanism is. So whether it's hardware, software, an assumption of use, user added, all the information that you may want to know to decide whether the safety mechanism is complete in itself, or we need to consider something somewhere else up and down the hierarchy. We need to say whether it's a configurable safety mechanism or not. So can it be switched on or off? What the diagnostic coverage is for the various levels. Then to tie all of that, we have a safety mechanism failure mode linkage element. And all that is simply doing is saying the safety mechanism name, the failure mode name, what FMEDA they're in, and whether this link is active and what the contributions are. And in that way, for the leaf cells at the very base level, we can try and encapsulate all of the data we would need to share, whether it's up and down a hierarchy, whether it's importing a block from a third party, or passing an entire IP on to another party. Okay, next slide, please. So here is an example of what you may want for an interlayer exchange of data. So say you're an IP provider, you've done your FMEDA analysis on a system element out of context, and we wish to pass the information we've got on to the next team who are importing your data. As you can see here, the table's trying to represent the type of information that we would be pulling in. So you've got your parts and the subparts. You then have the failure modes tied to those subparts. We have the failure mode effects and what contribution they're making to the failure mode, whether they're safety relevant or not, whether this is in mission mode or not, and also the technology we're covering. So whether it's digital, RAM, ROM. Obviously, it could be many others as well if analog. Those failure mode effects are then can be used by the team that's importing it to know the things that they will need to concentrate on and the things that they would then need to handle in their safety analysis for their block. Okay. Thank you. Next slide. So, methodology discussions. As Alessandra alluded to earlier, we've had some very active discussions on what should be included and how we should go about it. And here we've got two of the more active discussions we've had recently. The first one is, can subparts have subparts, and what about even elementary subparts? Because elementary subparts are discussed in the ISO 26262 standard. And it probably depends upon your view of what is a design part. If your design part is the top, then is your subpart in this diagram the AFE or dig blocks, or are they in fact new design parts yourself, which then have subparts within it? However we define our system, we have to be able to cover all of the different scenarios that would possibly be wanted. And the latest suggestion we're discussing is allowing having subparts within subparts and somehow defining it. If we have these subparts within subparts, then we also need to be able to support hierarchical named plans. So, for example, if you're doing an SOC, it's typically broken down into subsystems. Now, the SOC will have its own FMEDA. The subsystems will have their own FMEDAs, and those FMEDAs will need to reference the FMEDAs with the design parts within them. Now, the design parts within them do not necessarily have to be unique, because the same design part could be instantiated in more than one subsystem. And then the decision has to be taken, how are we actually going to merge that data? Do we want to take what could potentially be hundreds to thousands of failure modes from the lower level into the subsystem and higher up? So when you time you get to the SOC, you potentially got tens of thousands of failure modes, or do you somehow need to aggregate that and present a more simplified level to make the analysis more tractable? If I've got that information coming from a lower level FMEDA, do I need to capture the naming of that so I can localize exactly where that contributions come from? Or can we assume a level of, if you like, I'm hesitating to call it averaging, but grouping it together to give yourself some composed numbers rather than lots of broken down ones? This is something which is still actively under discussion and not decided, but what you can consider is that for the SOC point of view, the subsystems are subparts and the SOC is a part itself. Then within the subsystem, that is a part, and the lower bits are then subparts. It depends on the point of view you're taking when these are being done. Okay, next slide of this would be future work. Alessandra, please, are you still there?
I'm here. Okay. Vatsa, do you mind going to the next one, please? Okay, so let me share that because I think you're missing one slide, okay?
Sure, sorry about that.
No problem at all. Okay. And I just realized my background changed. Hopefully that's not the problem. Can you see the slides?
Yes.
Perfect. Okay. So I hope you got a good grasp of the data model we're trying to build and some of the challenges that we're facing. If there's time, we'll mention a few more of them because I think it's actually very interesting, the type of discussions that are coming out. Anyway, before we go there, I think I wanted to summarize a little bit how we are staging the work. Okay, and this picture is very busy, but let me, mention a little bit of what we think are the topics for future investigation that we feel are connected to this data model. Okay, so at the top in the blue, like you'll see ISO 26262, IC 61508. So those are the, so to say, big categories of work. And as I mentioned at the beginning, we are starting with ISO, and that's why we have a green box in there. That's where we are focusing on first. But what we would like to see is that this work also makes retargeting easy, retargeting to other markets. So if you have developed something for automotive, that it can be easily retargeted using the same data model for industrial, for example. And then I listed as a box also other standards. So we talked about medical and avionics. We do feel that there will be more work from the group to understand the requirements and the differences. Okay. So in general, the way the groups operate is first gather the requirement and then execute on what we feel the requirements are, and then finalize with publication. And we have followed that model at the beginning as a proposed working group, and we are still following it as a working group. And you'll see what I mean by that here. So in green, you'll see that the goal for us has been like release 1.0 or whatever we want to call it, is going to be covering the FMEDA core for IPs and components. Okay. And then what we see upcoming are the other boxes, extending and checking. Is the data model we have done also applicable for module and system, or do we need any modifications? Then, if you remember the picture I showed at the beginning where we have the functional safety data at the center and different other work products, you'll recognize them here: assumptions of use, safety requirements, safety manual, safety case. The coloring is kind of a little bit of how the work is how the group is working right now. The assumptions of use and safety requirements are being worked on in the requirement gathering phase. So we're trying to figure out, do we have anything to contribute here? Is there a pain point that the group can contribute on or not? Okay, so that's where we're at. And then we had a lot of interest. So the light yellow is a lot of interest for making sure that we can connect to the safety manual and to the FMEDA for industrial. Okay. And then the last box at the bottom, close to the bottom left, other work products and operations, is, for example, FTA, DFA, verification and validation. Okay. So an explanation of the box, the spheres that you see, the circles that you see on the right. The centermost blue box is our FMEDA data model. That's what Vatsa and Darren have covered in details. What we do feel is in any other topic that is connected, there will be two categories. The core of that topic. So let's say safety requirements. That could be a data model for capturing safety requirements. It could be in need of development. It could be already available, or it could be not a problem that we want to address. Okay, but that's what the blue bubbles are. And then the arrows, the blue arrows inside the yellow circle, are the connection to the FMEDA model that we are developing. So what in the requirement gathering phase, what we might find is that there is a blue bubble completely new that we need to work on. We might decide to do it or not. But then there is the connection in between that blue bubble and our data model. I'll give you an example. For FMEDA, we might decide to add for FMEDA to safety requirements connection, we might decide to add a field, an attribute to the list that Darren shown, that is connecting your FMEDA roles to safety requirements or safety goals So there could be that we introduce something specifically for a connection or not. It depends on the requirements. But that what this blue bubbles means with the yellow connection, okay? And so there are quite a few of this. And then I've only mentioned, reliability and availability there. There could be specific attributes that we need. One thing I want to specify is whenever we have a discussion, let's say about reliability or availability, or let's say about even FMEDA, when we talk about the data model, most of the time it's capturing guidelines that are already existing, but sometimes there are a lot of methodology discussions. So this group is not just capturing a data model of something that is well established. We also see a lot of methodology discussions that are coming out of this. I'll give you an example that is very simple on, let's say you have two safety mechanisms covering the same failure mode. Do we have a way to specify, how do I compound them? How do I compose them? Do I pick the max? Do I pick the sum and max it to 100%? Do I do a residual composition? Like, what do I do with those? And so there is a lot of methodology discussion about that as well. So it's not just capturing attributes for something that is established. There could be methodology discussions attached. Sometimes there are, sometimes there aren't, okay? So if you go to the next slide, I'll show an example of, the type of questions that could be open when we talk about these other connections.
Alessandra,
I'm sorry, yes, I'm sorry, guys. My brain is gone. So here, the next slide. So here's an example of things that we consider when we, for example, look at safety verification and validation. We haven't looked at them yet, though they start creeping in. So whenever we started talking about FMEDA, then we started talking about diagnostic point and about observation points. And then we explicitly and consciously decided to postpone them as a second version because we feel there is much more that needs to be discussed. So there will be questions about, fault simulation, formal methods, analytical methods, structural analysis. They all capture something slightly different about verification and validation. How do we capture all of this and combine it into FMEDA? How do they affect FTA or DFA? Yes. So this is just an example of the adjacent topics that we feel are very much connected to our data model that we are starting to see and that we plan to develop full-fledged right after we're done with the initial data model. So with that, I think I'll stop. If just one last word, which is thank you very much for the attention. We'll go to the questions. We are very happy if you want to join us. We have, at this point, I think, 20, 30 entities in the group. But we are very much welcoming newcomers, fresh pair of eyes. We have had a couple of companies that have joined lately that have been invaluable into, reviewing the work that the company has done. It's like when you are old friends in the end after 2 years of work, you finally understand each other and whether that's the right language or not, that's another discussion. And so once we got to that point, having a fresh pair of eyes has been invaluable for us, that we were not just, understanding each other just because we spent 2 years together. That's not the goal of a language, right? So if you're interested in joining, more information into these two websites, and feel free to reach out to any of us if you want to know more. Okay, so I'll stop here and see if there are any questions. Let me see if in the chat. So I'll stop sharing for a second. Let's see. If anybody has any question, if you feel that it's a little bit more complicated than just typing, let us know. Otherwise, I think there are a few questions that are coming up very often that I think I like to ask to Vatsa and Darren.
Hi, I got a question. Can you hear me?
Yes,
Yes.
go ahead.
Okay, so the functional safety workup is going to define a functional safety model. How does it relate to the existing functional safety tools that the EDA offers in the marketplace right now? Like, does it use as an input to those tools or output of it? Yeah.
Vatsa, Darren, do you want to give it a shot?
Yeah, I can.
You are the automation evangelist, right?
Yeah, so I can, right? So a great question. So the idea is who are the consumers of this particular data model, right? Exactly. We have a lot of these EDA tool vendors who are already plugged in. So you name the top ones, you already find them participating in this group. So in a way, all the EDA companies are focusing on and understanding these data models so that they can actually update their tools and flows and techniques, right? And also, we have a lot of chip makers like these internal CAD organization, EDA members who are actually looking into the functional safety and cross-checking whether it maps to their internal company, the way they deal with their data models. And of course, the IP component, functional safety managers and architects, they need to know these data models, right? And so they are also aware and they are actively participating in this quorum so that when they deliver, now they have a standardized technique to send these work products to the next level of hierarchy or the customers. And of course, the assessors, tier 1 customers, they are all should be aware of these data models so that eventually we will standardize these formats. So in a nutshell, what we are trying to do is trying to streamline and standardize these data models by giving certain level of abstraction, but without having any ambiguity and also incompleteness. So that's the hope based on these data models, I guess. Did I answer your question?
Okay, thanks a lot.
Okay.
Any other question, guys? Okay, so I think one question that I've seen coming up in other discussions has been around, what I mentioned at the end, validation and verification. And one angle is the data model, which is what we somehow mentioned. But I think there is a lot of discussion in the community around methodologies themselves. How much standardization is going to happen around best practices, different people do different things. Anybody, guys, Darren, Vatsa, do you want to cover, you got that question? Do you have any opinion on that?
Yep, I'll take that one. I think there's a lot of opportunity here for standardization because, as you say, there are lots of tools out there for doing it, and we're all doing elements of the proving of the safety mechanisms at different levels. So for an example, at the IP level, we will, even during the standard functional verification, be introducing faults to prove that just get the line coverage before we've even moved to more dedicated fault injection tools. But I need a way of capturing that information so I can use it in my FMEDA and I can pass it up to the next level. Because when it comes to the SOC, they may be wanting to do a statistical fault injection to test their coverage, but they could leverage that information from the lower levels to reduce the state space or knock out things which have already been proven so that they don't have to repeat the process. So I kind of see the model we're working on is the first step, and we can then move it on to say, how do we capture that information? If I've got a failure mode, what parts of the design is it actually covering, and then how do I store that information in a standardized way so that even if I'm using different tools, whether it be formal fault simulation tools from whichever vendor, we can start to pull that information together and make one coherent whole. And also so that when I deliver the IP to whoever is buying it or taking it on from me, I can give it to them in a way that they can also use it.
Thank you, Darren. Any question from anybody else? Don't leave me an empty mic because I'm going to talk. Okay, so I think one thing I'd like to share, since we have a little bit of time, we wanted to put a few more slides, but then we kind of limited because we wanted to actually stay within the 45 minutes. But I will use this opportunity to share with the group a little bit of the topics, and you got a glimpse from Darren, but some of the points that are being discussed, because I do think they show the type of discussions that are happening and the type of work the group is doing. So as I said, we were planning to publish in Q1, and here are, I'm going to list some of the points, and Darren, Vatsa, add me out if I forgot some of the points that are, keeping us awake or keeping us really busy, okay? So one, I think, is what Darren mentioned, a discussion whether multiple subparts are allowed, okay? So in the functional safety hierarchy, because what we have seen most of the time is, parts, subpart, and failure modes, or parts, subparts, elementary subparts, and failure modes. And so that question, as I think we have had, I don't know, 10 meetings around it. And I think the argument in favor of that is the type of complexity that is coming up with, especially with the SOCs. And the argument against that is, well, but I'm trying to capture just the functionality at the high level. So, and, to be able to model that, I should be able to reflect it in this high level failure mode or failure mode effects. And I don't need to keep track of all of my hierarchy. So that's one, one big debate. The other big debate, and if anybody, feels they want to share something or to, give us feedback, please do, because we are very used at this point to discuss about these topics. And so the other topic has been the elementary subparts. It is mentioned in a few places in ISO, but we're not seeing it very often in regular FMEDAs. Regular meaning, we're not seeing them very often. But what we do see is that people use them to kind of partition the design, getting more granularity. And so what we're trying to reconcile is the practice with the theoretical definition of ISO. So that's another topic. And then another topic that we've been just starting because we were so busy with the first two is, can I define failure modes only? And that's what I think Darren was also showing in the graphs. Can I define failure modes only at the leaves of my functional safety hierarchy? So I have a part, a subpart, and then failure modes. Or can I also have parts and failure modes? And so at the same level, so to say, I have failure modes and subparts as children of a part. Is that allowed? Yes, no, right? So that's another question. One more question.
Alessandra, associated to that is basically, if you are considering failure mode at parts and as well as at leaf node, how do you aggregate it, right? So that's something that, yeah.
Yes, absolutely.
Yeah, so that's something that the group is actually actively discussing. Again, very active participation, because once you start thinking about aggregation, what is the weightage? Whether is it a summation, or does part has a significantly higher weightage and things like that? These are some of the, again, interesting topics that are getting discussed. Just wanted to remind you.
Absolutely. And I'll mention the last one, and guys, intervene with anything if you want, that you are more interesting to say. But I think the last one is hierarchical composition, connecting also to what Vatsa was saying. We started discussing, we have a data model that we have initially refined for, let's say, an IP. But what if I have hierarchical IPs, or when I compose them at the SOC level, is this data model good enough? That's one question. But then second, which is connected to that and connected to what Vatsa is saying, do we need to also define how to compress, like some rules to compress an FMEDA from the provider to the integrator, for example? So these are, or not. Maybe the data model doesn't need to talk about how to compress. Yeah. And I think these are the most lively one. We have some past ones, which are, is a failure mode connected to only one technology element, meaning every failure mode is either only digital or only analog. I think these were the most active ones. And I know we don't have many minutes left, but anything else, Darren, Vatsa, that you want to share about either what's your biggest challenge that you have in your daily work, or, you know, what should we do next as a group, or anything that you want to share before, you know, we close?
I think the biggest challenge I'm facing in my current role is, what do you actually put into the FMEDA as a failure mode? And people are looking at this going, well, I'm trying to define what my failure modes are for registers. Surely everyone in the world's doing registers. There should be a library I can go and look up and just pull this in to make it easier, and hence just speed it up. So until your teams kind of develop that expertise, it can be quite labor intensive. So defining a model and then allowing you to construct those libraries, and perhaps in conjunction with work, say the P2851 is doing, actually construct some of those libraries, we can start to make this less labor intensive operation.
Very good point. Very good point.
Yeah. Yeah, again, not only labor intensive, but also standardization, because once you open it up to somebody's interpretation, right? One IP person can probably stick to this commission, omission, those 4 flavors and start defining the failure mode. Whereas similar register on a different IP of the same organization will start describing it in a different way. So once we have a library and a repository of, hey, if it is a library, this is how it has, these are the possible failure modes, that gives the guardrails and make it standardized. So when the organization goes to an assessor or to the next level of hierarchy, it makes like a homogeneous mixture rather than having all over the place.
Very true. Thank you so much, Vatsa. Any last minute question? No? So Darren, Vatsa, thank you very much. First of all, for the work you do in the team, and then second, for the presentation today. And thank you very much, everybody, for attending. Have a good day.
Thanks, Alessandra. Bye.
Thank you.
Bye.